The ship that saved every living creature on Earth was built by a man with no shipbuilding tradition, no professional crew, no dry dock, and no blueprint drawn by human hands, and the vessel he produced has been calculated by naval engineers working with the exact dimensions recorded in the Bible to have been one of the most structurally stable hull forms ever conceived for surviving open ocean chaos. That is where this story begins, not with the miracle of the flood, but with the miracle of the construction that came before it. The moment Noah received the commission, he was not standing in a coastal city surrounded by experienced craftsmen and timber merchants. The world of his time, as the ancient text describes it, was a civilization that had grown sophisticated in many ways: metalworking, agriculture, urban organization, but Noah's task was categorically different from anything anyone around him was doing. He was asked to build something so large that its dimensions would not be matched by any known vessel until the late 19th century, roughly 4,300 years later. That is not a poetic exaggeration. The ark as described in Genesis, 300 cubits long, 50 cubits wide, and 30 cubits tall, translates to approximately 137 meters in length, 23 meters in width, and nearly 14 meters in height, depending on which cubit standard is applied. The Great Eastern, the iron steamship that stunned the Victorian world when it launched in 1858, was the first vessel to measurably surpass those dimensions. For more than 4 millennia, the ark held a scale that human engineering had not been asked to exceed. When you sit with that number, not as theology but as a construction problem, the weight of what Noah faced becomes real in a completely different way. Wood was the material, and the specific word used in the original Hebrew text is gopher wood, a term that appears exactly once in all of ancient literature, right here, in this passage, and nowhere else. That linguistic uniqueness has fascinated scholars for centuries. It is not the word for cedar, not for acacia, not for any timber whose ancient name we can trace with certainty. Some have argued it refers to cypress, which was prized in the ancient Near East for its water resistance and was used extensively in boat construction across Mesopotamian and Mediterranean cultures. Others have proposed a form of laminated or treated wood, interpreting the root of the word as connected to resin or pitch-like properties. What makes this more interesting rather than less is the fact that the text immediately after specifies that Noah was to coat the entire vessel inside and out with pitch, a waterproofing material that ancient builders used with great sophistication. The use of natural bitumen as a sealant is one of the oldest and best documented construction technologies in the ancient Near East. Archaeological evidence from Mesopotamia confirms that waterproofing with bituminous compounds was standard practice for watercraft, storage vessels, and even architectural elements thousands of years before this narrative is set. Noah was not inventing waterproofing. He was applying known technology at an unprecedented scale. The structure the text describes is not a boat in the conventional sense. It has no described rudder, no sail, no oar system, no steering mechanism of any kind. It is, in the most precise architectural sense, a floating box, what naval architects call a barge hull or a displacement box, and this design choice turns out to be deeply rational once you understand what it was built for. A pointed hull optimized for navigation is faster and more maneuverable, but it sacrifices internal volume and increases the stress on the structure during heavy rolling. A box hull, by contrast, maximizes internal volume for its footprint, distributes weight more evenly, and has a lower center of gravity relative to its buoyancy, which makes it extraordinarily resistant to capsizing. Computer modeling of the ark's biblical proportions conducted by naval architecture programs at universities in Korea and elsewhere has consistently found that the length-to-width ratio of approximately 6:1 sits within the optimal range for stability in rough seas. The ark was not designed to go anywhere. It was designed to survive. And the shape chosen accomplishes that specific goal with a precision that is either a remarkable coincidence or evidence that whoever specified those dimensions understood naval physics at a level that still holds up under modern analysis. The interior organization described in the text involves 3 decks and a series of internal rooms or compartments, the Hebrew word used being kinim, which is most naturally translated as cells or nesting compartments. The 3-deck structure is significant from an engineering perspective because horizontal decking is what gives a large wooden vessel its rigidity against the racking forces that open ocean movement generates. Without internal decking, a hull of that length would flex, eventually work apart at its seams. The compartmentalization also serves the structural purpose of creating a series of internal frames that resist the lateral deformation of the hull walls. Ancient shipbuilders discovered through generations of trial and error that dividing a hull's interior into compartments dramatically extended its structural life. The text prescribes this arrangement not as an afterthought of convenience for housing animals but as a structural necessity that any experienced shipwright would recognize immediately. Whether one reads the text as divine instruction or as the recorded memory of genuine ancient engineering, what it describes is correct. Building at this scale with hand tools would have required an organized workforce, and here is where the human texture of the project becomes vivid. The felling of timber alone, assuming cypress or another dense hardwood, would have meant finding, identifying and cutting trees of sufficient size to provide the keel components and structural beams, which for a vessel of this length would need to be among the largest specimens available in the region. Ancient Near Eastern forests in the periods preceding major historical events were considerably more extensive than what survives today, and access to large timber was a critical resource that ancient kings and builders guarded jealously. The cedars of Lebanon were considered so precious that their transport and use were matters of international diplomacy. Noah's timber sourcing was not a background detail. It was a major logistical undertaking that would have required knowledge of where quality timber grew, the means to harvest it without metal saws of industrial scale, and a system for transporting enormous logs to a construction site. The text does not specify how any of this was accomplished, which is precisely what makes it worth thinking about, because the silence of the text around these practical details does not make the problems disappear. Someone solved them. Joinery is the heart of large wooden construction, and ancient craftsmen were extraordinarily skilled at it. Egyptian wooden vessels from the 3rd millennium BCE, preserved in desert conditions near the pyramids, show mortise and tenon joinery of a sophistication that modern woodworkers still admire. Mesopotamian boat-building traditions, which are the geographic and cultural context most immediately relevant to the Noah narrative, involved layered plank construction with careful caulking and waterproofing between each layer. The construction of a vessel at the ark scale would have required thousands of individual joints, each one needing to be tight enough to prevent water infiltration under the pressures and flexing of open ocean conditions. The pitch coating described in the text was not a substitute for good joinery. It was the final layer applied over already sound construction, a belt and suspenders approach to waterproofing that any experienced builder would recognize as correct procedure. You seal a vessel well not because you expect the joints to fail but because you know that even a perfect joint will be stressed in ways that a coating can compensate for. The timeline the text provides is one of the most discussed numerical details in the entire narrative. Some traditional readings interpret the construction period as spanning decades, and this is not an unreasonable interpretation given the scale of the task. Building a vessel of 137 meters from felled timber using human labor and hand tools is not a project that could be completed in a single season or even a few years. By comparison, the construction of large wooden warships in the 17th and 18th centuries, when shipbuilding was a highly organized professional industry with established dockyards, specialized craftsmen, pre-cut lumber supplies and royal funding, typically required between 1 and 3 years for vessels significantly smaller than the ark's described dimensions. Ancient Egyptian records show that large ceremonial barks required years of dedicated labor by organized teams of craftsmen. The idea that Noah's project took decades is not theological inflation. It is what the practical reality of the task demands. This was a generational commitment, a project that would have defined the entire productive life of everyone involved. Consider for a moment what it would have felt like to be a neighbor watching this construction. The ark, if built where traditional accounts suggest, in a region of ancient Mesopotamia or the broader Near East interior, was being assembled far from the sea, in a landscape with no navigable water large enough to float a vessel of its size. This has struck skeptics as absurd and believers as a test of faith, but from a pure construction logic standpoint it is also the most practical approach. You do not want to build an enormous hull on a waterfront where tidal action, flooding, and the instability of saturated ground would complicate foundation work. You build on solid ground where the structure can be properly supported as it grows, and you trust that the water will come to you. The largest wooden structures in ancient history, including temples and palaces, were built far from the environments they were ultimately designed to interact with. The timber for Egyptian monuments was floated down the Nile from forests' days of travel upstream. Building inland and transporting by water was standard practice, not a contradiction. The question that genuinely deserves a moment of reflection here, and one worth leaving in the comments below: if you were given the exact dimensions of the Ark, unlimited time, access to ancient tools and materials, and a team of willing workers with no specialized shipbuilding training, do you think you could actually build it? What part of the process do you think would break down first, the timber sourcing, the joinery at scale, the waterproofing, or something else entirely? The question is not hypothetical in the way it might seem, because experimental archaeologists have actually attempted to reconstruct ancient vessels using only period-accurate tools and methods, and the results consistently reveal that the hardest part is never the obvious part. The animals represent the aspect of the construction narrative that transitions most naturally from engineering to theology, but even here the practical organization problem is worth examining on its own terms. The three-deck structure with its internal compartments would have created a system of separated spaces that, if managed with the kind of systematic thinking the rest of the construction implies, could have housed a large and varied population of animals with each species isolated from incompatible neighbors. Ancient Egyptians transported live animals over long distances, as documented in tomb paintings and administrative records, and developed sophisticated knowledge of animal husbandry under confinement. The care and feeding of large numbers of animals over extended periods was not alien to the ancient world. It was a logistical challenge that agricultural and nomadic cultures dealt with regularly. Scaling it up to the Ark's described population is the theological leap, but the organizational knowledge to manage what is described was genuinely present in the ancient world. Ventilation is a detail the text addresses directly, and it is a detail that reveals careful thinking about the practical requirements of the structure. The Hebrew word sohar, often translated as window or roof opening, describes a light and air source running along the top of the vessel below the roof line. In a sealed wooden vessel carrying a large number of animals across multiple decks, ventilation is not a luxury. It is a survival requirement. Without adequate air circulation, the buildup of carbon dioxide, methane and humidity in a closed environment would create conditions lethal to both animals and humans within days. The specification of a continuous opening near the roofline creates a stack effect, where warm air and gases rise and exit through the upper opening while drawing fresher air in from lower points. This is the same principle used in ancient granaries, stables and underground storage facilities across the ancient world, and it works. The fact that this specific engineering detail is present in the text suggests either divine instruction or a narrator who understood the practical requirements of enclosed animal habitation well enough to include the one detail that makes the whole system viable. The door that was sealed from outside, as the text describes, has generated enormous amounts of theological commentary, but from a construction standpoint it represents one of the most technically demanding elements of the entire vessel. A watertight door in a wooden hull at the scale of the Ark would need to be framed into the hull in a way that distributes the pressure of water along its entire perimeter rather than concentrating stress at the hinges or latching points. Ancient shipbuilders in Egypt and Mesopotamia developed sophisticated methods for creating watertight seals in wooden structures, using combinations of fitted wood, fiber caulking, and bituminous pitch applied in layers. The door of the Ark, whatever its precise dimensions, was not a detail that could be improvised. It required the same careful engineering attention as every other element of the hull. And the act of sealing it from outside, whatever theological meaning that carries, also makes structural sense. The exterior application of pitch to seal the door frame from outside would have been more thorough and effective than any interior application could achieve. What Noah built, regardless of how one approaches the theological dimensions of the story, represents something that rewards serious attention as an engineering narrative. The dimensions are not arbitrary. The materials specified are not random. The structural features described, the three decks, the internal compartment, the ventilation opening, the pitch coating inside and out, form a coherent engineering system whose components work together in ways that ancient builders understood through hard-won practical knowledge and that modern analysis continues to find structurally rational. The story has been told for thousands of years primarily as a story about faith and divine command, and there is no reason to separate those dimensions from the engineering reality. But the engineering reality is remarkable enough to stand on its own terms, and it deserves to be seen clearly. The reason this matters beyond the story itself is what it reveals about the depth of practical knowledge that ancient people carried. We have a tendency, even now, to imagine ancient builders as people working mostly on instinct and luck, occasionally stumbling onto correct solutions. What the Ark narrative describes, when read carefully as a construction document, is something else entirely. It describes people who understood buoyancy and stability, who knew the properties of waterproofing materials, who could conceptualize a three-dimensional structure of unprecedented scale and work through the sequential logic of building it from the ground up, and who thought carefully enough about the interior environment to specify ventilation in a way that would keep its inhabitants alive. These were not primitive guesses. They were the applied knowledge of a civilization that had been solving hard practical problems for generations, and whose solutions were accurate enough that they were worth recording and transmitting to every subsequent generation that read the text. Every time you look at a modern ship, from a container vessel crossing the Pacific to a ferry cutting through morning fog, you are looking at the descendant of a tradition of accumulated knowledge about how wood and then metal can be shaped to float, to survive, and to carry life safely across water. That tradition did not begin with the Industrial Revolution or even with the great shipbuilding cultures of the ancient Mediterranean. It began with people who looked at enormous challenges and worked through them methodically, who asked what shape a hull needs to be to survive a storm, what material keeps water out under pressure, how you keep air moving through an enclosed space, how you make a joint that holds under flex and stress. Noah's story, read this way, is not separate from that tradition. It is its most dramatic expression, a moment when everything that practical human knowledge had accumulated about working with wood, with water, with living things, was brought to bear on the largest construction challenge one person had ever been asked to face. The fact that the vessel he built has outlasted every civilization that doubted it, surviving not in the wood but in the precise dimensions and structural logic that are still being analyzed today, is its own kind of permanence. If this is the kind of content that makes you see the ancient world differently, subscribe so you do not miss what comes next, and if you know someone who thinks ancient people were just guessing their way through history, send them this video, because the numbers here tell a very different story.